Hello, this is Jim McCune with ITG3D, and we have a little project today I thought I'd share with you. And it is we're going to try to reproduce this part. It's an automotive part for 1968, 1970 era Chrysler, Plymouth, Dodge products. So this is a 50-year-old part, which is no longer in production, obviously. And the repops are substandard quality, and everybody complains about they're hard to install, they're brittle, and a lot of other things. So we're going to try to reproduce this. And at closer inspection, you can see this black coating that's put on it. It's kind of a fuzzy coating, like a material. And what it is, it's called flocking, Flocking. And it is a treatment used on the interior of that period of glove boxes, dashboards. It's kind of got a suede type appearance to it. And this is a window channel for the front of the driver and passenger side windows as they roll up and down in this deep channel here. And so you can see this is pretty dilapidated and it's just falling apart. And obviously that's why they want to replace it. At any rate, we have narrowed down the material, and what we're going to reproduce it as is a polycarbonate sheet, which we'll cut into strips. And to get the form that this carries, and you can see it's a rather complex shape. It starts in here, comes out, up, over, up again, then reverses itself 180 degrees and then back over to form the other side. And so there's not much room in here to form with, because what you normally think of when you see all these 90 and 180 degree turns is a press brake. But to get the tooling in and out of this area you have remaining and in this deep slot, a press brake is going to be very difficult to do that with and require some pretty specialized tooling if you can do it at all. What we're going to try to do is called roll forming. And roll forming basically takes this strip, a wide flat sheet, and sends it through a series of rollers to come out with this net shape at the end. So from this we'll go into Fusion 360, and I'll show you a little more of what I'm talking about in terms of the roll flour and the roll form. Okay, so this is what's known as a roll flour. It's basically all the positions that the flat material will be molded into through the rolls, or as it passes through the rolls. To make this a little easier to follow, I've broken it out into individual steps that you'll see. And the first thing you'll see here is a straight line with the dots in there indicating where the joints are going to be. And the first roller basically just guides everything straight into the roll mill. The first operation in the roll mill is to bend the 90 degrees on the outside edge of the material. The second step in is to make the next 90 degree bend. Then the third step will flip that down 90 degrees on each side. The next step will be to flip it back up, flip this section here up 90 degrees. And then we're going to flip this over. This is a transition move. I didn't put the transition moves in the others, but basically everything that's a 90 will take to a 45 first, and then through the roll that makes the 90 degree bend. So here you see the 45 degree bend, and there's the 90 degree bend that brings it back over. The final bend being the one in the dead center of the material to make the U channel that the window goes up and down in. So basically everything on this side, this side, this side, down, over, up, over to the center, and back down around the other side will be the black flocking. And the side that's outside, here, and then inside this, will be untreated material with no flocking on it. So from here we go to designing our individual rolls. Okay, so what you see here are the rollers, and this particular roller is the 90-degree roller for that first bend. And you can see here, you've got a flange that comes up, you've got the roller that goes down in between, which the material already having been at 45 degrees will go ahead and go in that section there and be bent to a 90-degree roll. That's the first one. And so we have to have some way to support this. So what we do is we use a head frame with a top rack, and we center through that with bolts, obviously, to make an axle, and do that on both sides. So it's fully supported. So we'll do that with the rest of the rollers and the rest of the head frames to finish up that first 90-degree bend and start the next bend out. And so what we end up looks like something like this. And of course, all this is mounted to a base. And so what you end up with is a series of rollers, the first one guiding it, the second one making a 45, the next one making a 90, the next one making a 45, the next one making a 90, all the way out through until we finish up all these bends. Now, we're going to have to get kind of creative on some of this because it's not going to be able to use a top roller, bottom roller. It's going to have some side rollers and some things like that. So we'll bring you back to the Fusion 360 model when we get to that point. But for now, it's off to the 3D printer. So as you can see, we're back from the 3D printer, and we've finished our parts. There are basically a series of parts. You have the frame stand, which looks like this. You have the head frame, or the top of the frame, which looks like this. And you have the rollers, top and bottom rollers, each width and shape of the bottom roller determined by which bend you're trying to form. So let's talk about the design of these a little bit. Now that you can see, because the part is 3D printed, I've placed fillets in these areas where the side of the tower comes down to the base, and it's filleted all the way around. When we produce this in metal, we'll eliminate those fillets. They're needed because of the way the layers are formed in the 3D print. It gives it a stronger attachment to the base for this side to have these fillets on here. It's just a wider area and a smoother transition so you don't get stresses that snap this part off right at the base. As you can see, it has two holes for mounting it down to the base. It has a hole for the axle for the roller. It has two threaded holes up here to receive the bolts that will hold down the head frame. The head frame is radiused here where it comes up and over here where it comes up to be able to get the screws in and out that hold it down to the base. It also has an axle hole through the center, and for aesthetic purposes we rounded it off at the top and rounded the edges. The rollers, the top roller in this case, and in most cases, is a simple flat roller with no detail on it. The only important thing is the OD and the ID. The bottom roller is a little different situation. In the bottom roller, you not only have the width and the ID and OD of the part to consider, but you also have this shape out on the edge. And in this case, you can see this edge is meant to form a 45-degree angle when placed with the top roller on top of it like so. So what we'll do is now, we'll assemble this real quick. And so we've got a washer. I use a lot of washers with 3D printed parts. simply because to turn a bolt head, you'll cut into the plastic with the corners of that, and it also spreads the force of the bolt further out and includes more layers in that as it goes through. And so we put a washer inside and outside. The inside washer also gives us a bearing surface so we aren't rolling plastic against plastic. So there's less friction involved and less galling of the plastic to its other plastic neighbor. And so we have a washer on this side, and we have the other leg, another washer, a nut to catch the end. And we'll Loctite that nut in place once we've gotten the correct tension on here so that this rolls somewhat freely but doesn't rattle side to side. On the top, we do the same thing. We take a washer. If I can pick it up, we take a washer, run it through the outside of the top frame. Now we need our inside washer, our top roller, another washer, the other head frame, a washer, and a nut. Same thing on the tension, same thing with the Loctite. So this is placed obviously on here. And our top bolts to bolt the frame together go here. Now this allows us, we've made these rollers slightly oversized, and that allows us to put shims in between these to get exactly the right amount of space between them to grip the material firmly, yet still allow material to pass through. And so those are attached like that. So the next step is to take these and put them on a board, which we're going to use as the base for all of them. And we'll end up with a series of rolls like so. Actually, this one is here and this one is here. So we end up with a series of rolls. In this case, this forms the first bend of our part and prepares it with another 45 for the next bend. And then we'll print more of these as we go down the line to get all of the shapes. So you can see it's going to take quite a few rolls to form this entire part because it's a fairly complex part for roll forming. And this is an experiment. Hopefully it turns out and this works. We'll bring you back when we get these mounted down, and we will test running a strip through the first bend to see if we in fact get a 90-degree bend on each edge of the strip. Well, we have the frames and rollers assembled and attached to the base. I just used a 2x6, sanded it, painted it yellow for some contrast. The main thing was to get these laid out so that each roller has the same center line and all the frames are square, and it's attached down with these 1.5" number 10 self-drilling, self-tapping screws, and that goes through, lacking about 1/8 of an inch, going all the way through the 2x6 once they're installed in the frames. Pretty simple, pretty straightforward. Again, the main thing was getting these rolls exactly centered with one another so that it runs straight when you start running a strip through it. Getting off a little bit, 1 or 2 rollers is not that big a deal, but by the time this stretches out, remember now each one of these sets of 3 makes one bend, and in some cases it may take 4 or 5 rollers to get it into the net shape that we want to end up with. So this is going to extend out. This board is a little over 6 feet long, and hopefully I've left enough room to be able to get all the rolls in. I may be a little short, may have to add some on to the end of it, but we'll see about that when we get there. For now, we will adjourn from this and go into, this is the material we're sitting on here. We'll cut this into strips and apply the flocking. I'll cut it off camera, but we'll apply the flocking on camera so you could see how that process works. All right, we have our rolling mill set up and we're ready to test bend our first strip. And all I did was we're going to use the 1.5 thousandths thick polycarbonate in this test. And it's pretty flimsy. Hopefully it gains enough rigidity once it's bent to mimic the original part. If not, we've got some thicker material we'll try to run. My biggest concern is that there is enough clearance between the end of this roller and the edge of this roller at the flange, and there may not be because I didn't allow very much. But essentially, we'll feed this through and wow, that is tight. May have to shim that a little bit to get that to work. It'd be much easier if I had the cranks on this. Okay, I don't know if you can see that or not, but we have got a bend here on the 45 section. And now we go into the 90 section where I anticipate having some trouble. I'll pull this through a little bit to get some material to work with. And roll these rollers to hopefully pull that through. Rollers are very tight. Okay, and the good news is it's working basically like we want it. The bad news is we're going to have to redesign a few things to get it usable because it's very hard to advance the material through the rolls. We need some sort of a drive on each roller, or we need a more distance between the rolls, because that's about all the force I can put. On that. Yep, that's all the force I can put on that. But the good news is, it seems to be working. We are getting a 90-degree bend here. It's relaxing somewhat with spring back, but it is working. Let me get you a close-up shot so you can see how it progresses through the rolls. Okay, after doing some shimming, and I also shortened this roller because it was impinging upon the bottom roller. There just wasn't enough room for the material. We can now get the material through the roll mill just by pulling on it. And as you can see, we ended up with about a 45-degree bend because of the spring back of the material. So we're going to have to put some side rollers in the middle to go ahead and push that on over to what becomes a 90. Material wants to do it, just needs a little help. There you can see I've gotten a 90 on it just by pinching a little bit. And it has stiffened it up quite a bit. So hopefully we're on the right track and this material works. If not, we've got a thicker material we can run through. And we'll go with that. For now though, we need to design a side roller to pinch in after it comes out of the 90-degree roller and get rid of that spring back. Okay, when we left off last, we had bent through the first 3 rollers and our 90-degree had some spring back in it, and so we ended up with about a 45-degree net shape. So this is back in diffusion now. We're going to make a roller that is going to overbend that part 45 degrees, and hopefully that'll stand back up and approximate 90 degrees at that point. If not, we can play with this angle here on this top roller and get it to spring back to come out to 90 degrees like we want. The bottom roller is just a flat roller. The top roller is made up of 3 pieces. It's made up of an end roll on each end, and that has the 45 degrees on it. This over here could have been any degree you wanted. It could have been flat or whatever. I just made it a 45. And then the center roller is just a spacer between the 2 outer rollers to keep them where they belong. Now we may have to make this center roll spacer larger, because when this 45 and this 45 hit that, the material may tend to bow up in an arch in the middle. So we may have to increase the size of this spacer to keep that flat down so that the roller rolls 45 on either end. We'll just have to see how that happens. Okay, so here we have a look at the finished 3D printed overbend roller set. And we're going to give it a try here and see how it does. Let me move the camera around and we'll run a part through. All right, this is our strip we ran through before. And remember, we had about a 45-degree bend after the spring back happened. So if I can feed this through here without too much difficulty, it's going to flatten it back out, of course, in the first roller. Still going to have the problem feeding that I've had. There's the 45 degree. There's the 90-degree bend. And yeah, the overbend is not fitting in there right now. Not sure if I miscalculated my width. There we go. Okay, so now we're getting about a 45-degree overbend, and we'll run this part through. It is definitely getting the overbend. This side is bending up to 90 just fine. This side, while appearing to be bent the same amount, is not. I see a gap here, so it looks like I'm going to have to shim out this roller on the near side to you. And so you see we got a nice 90 on this side. This side, not so much. It's laid out at a 45 degree still because this roller here wasn't engaged in far enough. So I've got to put a shim in here to get that spaced out right so that both sides come out to a 90. I'm really happy with this side. It looks like the 45 degree overbend is just about the right amount to get that to come in perfect. So we will continue with that idea and get this shimmed in and run it through again. Okay, we did a little revamp. Thank goodness the 3D printing is much faster than producing this in metal. And you can see on the left the roller with the 45 on it. We increased the size of the roller in the middle to keep the material from arching up in the middle. And then you have the same roller on the outside. So we will now try to run a piece through and see what happens as far as our overbend equaling it back out to 90 degrees. Okay, I'm going to adjust this axle in just a little bit tighter to take up some of that slack in there. And we're going to feed the same piece of material through, which isn't a fantastic idea in that it has to iron it out flat before it can bend it. And we're not getting a true idea of what we're doing because we're bending back over the same area that we've already bent. If I can get it started. Okay, it's got it all flattened back out. Getting it into the second roller, which puts the 45 degree angle on it. Bring it up to the third roller, which puts the 90 on it. Again, it comes out about 45. We'll probably have to add some guides to this one. Get that material started rolling over to overbend. And it doesn't want to really go through. Get some material through here to work with. One of the things we're going to have to do very shortly is to make a drive mechanism for this. Okay, now we're through. So I can pull it through now. We are getting a 90 now when it springs back out of the overbend. And success. We have a true 90 on both ends. And we're ready to move in towards making the second bend at this point. We will have to put some sort of a guide here to start pushing the 90 degree bend over and get it into the overbend roller without having to fight with it. And we've got to get some sort of a drive mechanism on here to be able to push the material through without having to fight with it individually, roller by roller. But that's where we'll end up on this video. And Next video will be continuing on with the next bins and adding the top, some sort of a drive system to drive each roller to get the material through the entire system. So if you enjoyed this video, please like, subscribe would be great, and recommend it to anybody you think might be interested. It would help us out greatly. And we thank you for watching, and we'll see you in the next video.